Okay, so in the section System of Inequalities, Word Problems, we're going to be writing two inequalities, and then we're going to be solving for possible solutions for those inequalities that make both true. So this is very similar to what we did with lines and systems of lines when we wrote our word problems into equations and solved for them. Okay, so you want to look at all the information we have. We know that Evan is going to work 2 summer jobs. One of them is babysitting. One of them is walking dogs. We know that he makes $8 walking dogs and $10 an hour babysitting. Okay. We know that he wants to earn no less than $140 and work no more than 16 total hours. So no more than 16 hours means that 16 hours, it's going to be 16 hours or less. So less than or equal to 16. And he must earn no less than $140. So no less than $140. So it would have to be greater than or equal to 140. So those are 2 parts of our inequalities that we're going to be writing with the terminology that told us how to write it. Okay, and then we know that Evan is he wants to work 12 hours babysitting. So what the question's asking you to do is to find all the possible values for the number of whole hours walking dogs that he must work to meet his requirements. Okay, so the biggest part of that is whole hours he must spend walking dogs, because we don't want to include any decimals or fractions or half of an hour or 15 minutes. We don't want any of that. We want whole hours when we're writing our answers out. Okay, so all of the information we have here is enough in order to write our inequalities. The only thing we don't have are variables. So you are allowed to determine a variable for babysitting and determine a variable for walking dogs by choosing these variables yourself. I'm going to choose B and D just because babysitting B, walking dogs D. Okay, so I'm going to let B be the variable that symbolizes babysitting and D be the variable that symbolizes walking dogs. Okay, so the first inequality I want to write is the number of hours total that he's going to work. So if Evan walks dogs and he babysits, so B plus D, the number of hours babysitting plus the number of hours walking dogs, has to be less than or equal to 16 because he's not going to work any more than 16 hours. And then our second inequality, I'm going to write based on the total amount of money he works. So we know that he needs to make greater than or equal to $140 because it said no less than 140 by walking dogs and babysitting. Babysitting, he makes $10 an hour, plus walking dogs, he makes $8 an hour. So all of these hours that he's working will add up to be greater than or equal to $140. So here are 2 inequalities that we're going to be using now. And I'm going to erase this information because we're going to need to stop it. In the problem, we were given that he is going to babysit for 12 hours. And with that said, he wants to know how much he has to walk dogs in full hours, remember? So we can say that B equals 12 in order to solve for the possible solutions for D. So if B equals 12, our first equation, or our first inequality is going to be 12 plus D is greater than or equal to 16, or less than or equal to 16, I'm so sorry. Okay, because we're just plugging in that value of 12 right here for our B. And if we solve this, since we put a linear equation or a line, we get that D is less than or equal to 4. So that's one thing that we know for sure. Okay. Now, let's solve for, we're going to do that b equals 12 again, but for our second equation. So 10 times b, which would be 10 times 12, plus 8d is greater than or equal to 140. Now, 10 times 12 is just 120, plus 8d is greater than or equal to 140. And if we simplify this, subtract 120 from each side, we get 8d is greater than or equal to 20. And when you divide each side by 8, we have that d is greater than or equal to 2.5. So now that we know that d has to be greater than or equal to 2.5, but less than or equal to 4. So we want to tell our solutions are any whole number between 2.5 and 4. We have 3 is a solution between 2.5 and 4, and we have 4. Because if you looked at this on a number line, right, these are the whole numbers in ours. If this is 2.5 and this is 4, any whole numbers between 2.5 and 4 are a solution. Okay? 4 is included because d is less than or equal to 4, so that's definitely a whole number. And 3 is included because it's within that range and it's a whole number. We can't use 2.5 because it's not a whole number and it wants to know how many whole hours he would work. So our possible solutions would be 3 and 4. And I wrote it with a comma because it asks us to write it as a comma-separated list.